Now let's think about what you as a designer need to remember when you're designing a part out of plastic. As we mentioned last time, you're not only designing a product, you are designing a flow channel for a polymer. And what this means when you're working with your molder is that you can't just design the part and then say, all right, so now I got the part, I think I'm going to use acetal. No, I think I'm going to use acrylic. You have to select the material and then finalize the design of the part. And what this implies is that you should develop a working relationship. You should first select who you're going to use for your molder and then develop a working relationship with them, because they are in a position to advise you about what kinds of things will work with the kind of plastic you have selected. Probably the number one most important guideline when designing parts out of plastic is that you need uniform wall sections. Same thickness throughout. Even something like having sharp square corners gives non-uniform wall thickness, because down here in this sharp corner area you have more volume than you do in the rest of the place. If you do not have sharp corners, so here's a section through half of a gear, a plastic gear, and if you were to design the part this way, notice that you have thin places and thick places, and the result will be sink in the thick places, as either the part does not fill adequately because of these uneven thicknesses, and or it cools at a different rate and therefore shrinks at a different rate, and what you have is a bad part. So what you need to do when you're designing a part is look at the shape and then think about how could you rearrange that shape so that all the wall thicknesses were the same. And that's what you see in this redesigned section of the gear at the bottom of this slide. So this page is from GE Plastics. They have a design guide. A lot of plastic companies have design guides. And they're pointing out that think of this as a shell type. Whatever you're designing, it's a shell. As we'll see, plastic does not like sharp corners. One reason is stress risers, and another reason is you get places that sink. So you get too much stress and you get unequal shrinkage and unequal filling. So if you for some reason you can't have uniform wall thickness, if you have to go from a thicker to a thinner, at least give the part a gradual transition. Give it a slope, and if possible, radius the corners. Speaking of radius the corners, this is the other this is probably the number 2 important guideline, although I don't know, uniform wall thickness and radius all corners are both pretty darn important. So radius all corners, no sharp corners, period. Sharp corners cause a couple of things. One we just looked at a couple of slides ago. It causes non-uniform volume of plastic in the sharp corner, but it also causes what we call stress risers. In the sharp corner, the amount of stress in the part rises, it increases, and you will get cracks propagating, and then you will get a broken part. If you've taken the class Strength of Materials, you've thought about stress risers in sharp corners. So in plastic, just avoid sharp corners. We or labs test for resistance to stress risers. It's called impact strength, using the IZOD impact test. And it looks like this. A hammer pulls up, swings down, and smacks into this plastic sample, and the plastic sample has a sharp cornered notch in it, and then the company tests to see how vulnerable is it to cracking when it has a sharp corner. Related to uniform wall thicknesses, if you have a flat place and a rib, which you often have, the rib should be thinner than the rest of the part which it intersects. And you'll notice here that the guidelines are different for amorphous plastic and crystalline plastic. That's one of the examples of why you need to select the material first. If you have ribs and body all the same thickness, as we see in this example on the left, what you will get is a larger amount of volume in the corner area, and you will get sinks. And a sink is a place where the plastic has a depression. It's not flat across here. If you have the ribs thinner, you do not get a sink. Here's a guideline from GE Plastics. They also have suggestions about the height of the rib. A gusset is a triangular brace. It's essentially a triangular rib, and whatever guidelines you follow for ribs, you can follow for gussets. You want to pay attention to what direction your ribs are going, and if you've taken strength of materials, this is probably going to make you think of moment of inertia, stiffness of a shape. So this direction has a good moment of inertia, this direction, lousy moment of inertia. In other words, this way is stiffer. A boss is a raised cylindrical feature, so it's a bump that sticks up that you might be putting a bolt or a screw or a pin through. And here is a set of guidelines for the bosses. If the wall is too thin, that's bad. If the wall is too thick, that's bad. If the boss is too tall, that's bad. So there are some guidelines for the relationships between diameters and heights. Basically, you're avoiding small holes and deep holes, which act like small holes. For screws, you can have just a plain hole in the plastic and then use screws. It's better to use thread cutting screws. Thread forming screws create a high hoop stress, so thread cutting are better. You can also have molded in threads, and the way those are created are with mold inserts. So the tool and die maker, the mold maker, will place a retractable mold insert in the mold. And if you think about it a minute, you will realize, oh, so any of this fancy stuff like bosses, or especially molded in threads, make your mold more expensive, because now your mold maker has to figure out how to make a mold insert that will thread its way in, get molded over, thread its way back out, and get out of the way. So that's some extra mechanism. Anyhow, what this picture is showing us is avoid sharp corners, have round corners when you have threads. Another guideline is to think about where the mold fronts are going to come together. So in this picture on the lower right, here's the sprue, the runner, and the gate, and the material flowing in from the gate around each side of the part. Well, what's going to happen is over on the far side of the part, you'll get a knit line, and then you'll get a place where it doesn't fill. So you'll need to work with your molder and mold designer to figure out how can you make the right size and shape part so that you don't get that knit line. Also very important, no vertical edges. You need to be able to get the plastic part, out of the mold. And if your sides are at 90 degrees, if they're vertical, that thing is not coming out of there. If the sides are at a slope, and that's called draft, then it will come out of there. Now, something you really need to think about and maybe watch for if you are supervising other drafters, watch for is you might be designing a boss, let's say. Let's pretend this is a boss, not a U-shaped thing. And you're thinking, okay, so I need uniform wall thickness, so I'm going to have parallel sides, and I need them to be drafted so that they'll come out of the mold. And so you just do a thing like this. Well, because they're making a hole in the part, there's a core that has to go in to make the hole. And if this part has this kind of draft on the inside of the hole, surprise, that part's not coming out. So any place you have a vertical wall on your plastic part, you need draft. 5% draft is a good angle. You can get away with lower drafts depending on the part and the material. And here again, talk with your plastic molder to see what they recommend. This is just more of the same. All the vertical places where you might need to put draft: walls, ribs, gussets, bosses, holes. Then plan for ejection from the mold. Last time we talked about ejector pins and how they can leave marks on your part. So think about where can those ejector pins go and where do you have to avoid them. Another thing you have to avoid is parting lines, and these are different from knit lines. A parting line is the place where the two mold halves come together. And depending on the precision of the mold, you might get a little melted plastic squirting out between those two mold halves. That's called flash. And if you look at inexpensive plastic parts, like let's say plastic picnic spoons, you will almost always find some flash. In addition, you need to think about the tolerance. What is the tolerance for mismatch? If those two edges do not line up perfectly, how much misalignment can you tolerate? Then think about the mold surface. Now, if you have a smooth part like plastic picnic spoons, as I think we mentioned last time, those mold surfaces have to get refinished every so often. They get polished because after a certain amount of parts being made, there are wear marks inside the mold cavity and you don't have a smooth plastic part anymore. So you have to take your mold cavity, you ship it. Used to be you ship it, if you're in Oregon, you ship it to California and get it polished, and it costs a lot of money. Well, as an alternative, you can get your mold surface textured. Again, you have to send it to California, but it costs less than the polishing of the smooth mold. So this picture here is just a sample from one mold texturing company called Mold Tech. There are others, and I believe they use and I forget the technique. It's like a pentagram in the old toy days. So there's a mold pattern, and then there's like an electric eye that follows the mold pattern and etches the surface of the mold cavity to match the pattern, and you wind up with a mold cavity textured like, could be like leather or naugahyde or wood grain or sand or any of those. This page here gives guidelines about how deep the texturing should be. Here's R&D Plastics with just a summary of those guidelines. And finally, a couple of checklists. This is from SME, this is from Bayer Plastics, to help you think about, have you missed anything? Have you considered everything you need to consider before you meet with your molder?